Hello, welcome. You heard the topic, so let me introduce a little bit myself and a little bit Swiss Re. I'm data science director in Bratislava, where we have the biggest data science team in Swiss Re, almost 30 people, and we do the global projects. It starts with the machine learning, computer vision, but recently, in the last 2 years, it's lots of about Gen AI. And that's also the topic I would like to speak. Even though I'm now leading the team and the department, I was studying very close here at the FIT-STU, and I'm very happy to also see that how great the building of FA-STU is. Good. So I think you heard about all these things and all these changes. And we also in Swiss Re see in some way. So I will be very fast and try to introduce how we see the development, what we see changing, but also like give you one idea that probably you hopefully haven't heard. One is the first wave is the workplace productivity. We think that Gen AI will impact how we operate, how fast we are, what we do, and really the daily jobs. And in Swiss Re, we want that all the business users and basically all employees on Swiss Re have access to these tools and can apply them for their daily jobs, and they know the best how to get the benefit out of that. What you probably haven't heard is we behave to the standard tools, ChatGPT, Gemini, and all these other great machines like commodity. In the past, there were huge differences between each of these models. But right now, we consider that commodity. It's similar apple to apple. If you go to a shop and you are looking for apple, you don't care if it's apple probably from Lidl or apple from Tesco. It's still an apple. It can be green and it can be red. But there are not so many differences. And this is what we think the industry goes. This is commodity. We don't know which model will be the best one in 2 years. We also don't care. We know that it is developing. And what we rather do is, on our platform, on our main platform, we have an abstraction layer. Abstraction layer that you can easily change the models from one model to the next one because nobody knows which one is the best. What will be the best in 2 years? Like all the companies, if you go to OpenAI, if you go to Google, and if you go to any of the providers, all will tell you, and I put my hands into fire for that, all will tell you that their model will be best in 2 years. I'm quite sure. That's why we have extraction layer. We really want to behave to the like commodity, and we can easily exchange and change this model and test which one for the specific project is the best one. The second thing, I think you know about that, is like using the Gen AI for in one process. This is what we call business innovation. We really look at all the processes around, and we just try to find the one thing where we can improve it, make it faster, make it more even human-centric and easier to the users to do the work. And the last thing, what we call industry disruption, and this is all these agentic waves and reimaginations and all these nice things. I will not speak about that. We are also running in Swiss Re our proof of concept and the first projects. We think there is lots of potential, but this is not a presentation about that. Rather, I will speak about concrete product. Concrete product, how we did something concretely, but I don't want to speak about the product. I want to use only the product example, that this is how we did it in this concrete product, but that you get the learning on how to test your Gen AI systems. So I need to introduce you a little bit of what this system is about, but after that, we jump to the meat on the bone. This is unfortunately only the bone. So what is Life Guide? Life Guide, imagine that you have Wikipedia of life and health knowledge. You know that Swiss Re is reinsurance and insurance company. And what we do is we provide services to insurance companies. And one of these systems that we provide is Life Guide. Life Guide is basically Wikipedia. There are pages of medicinal and text by medicinal experts, and there are 10,000 of these pages with info about the facts of these illnesses, but also rating tables and conditions that you should apply to their direct insurance policies that you write. Like I was thinking that this will be like lots of students. There are students in the background, but in the first line, I see people that already have probably life and health insurance in some or other way around. Something risky that happens. This is the systems that with high chance, probably with 90% chance, your life and health provider used to underwrite you, to understand how risky you are. Why I think it's so many? Because we know that Life Guide, there are 12,000 users. These are the underwriters. And in each of the company, you have some local insurance company, they have 5, 10, 15 underwriters within the company for focusing on like a country like Slovakia. And we have there 12,000 users. There are hundreds of clients. We provide this in more than 100 of countries. And basically every second we get a hit. Some of these underwriters ask us about something from our medicinal knowledge that we built over 30 years. So you see it as a huge field. You can imagine that so many people use that. There is so many pages. No search solves all the problems, especially if it's multi-language and it's lots of complicated words and lots of complicated things. For example, probably some of the people snore, and that can be connected to sleep apnea. And sleep apnea can have some long-term impact on your health. I was not aware of that. I just read it, by the way, in the system. But the thing is, there are thousands and thousands of illnesses you can have, and the combinations, and each of them can combine, and it's very complicated. And the doctors would probably be able to speak about that for hours, but let's imagine that it's just like that. So this is how it can look like. Complex medicinal and non-medicinal knowledge. And if you imagine that you are the underwriter and somebody comes to you and wants to get the insurance policy, and you have that and that illness, you live in this and this and this place, this is your work and so on, you need to understand all these things, but you don't understand it as standalone and objects by object by object, and I understand your word. You need to connect this. You need to literally sum up all these risks in your life to get to the final knowledge. And the companies are using this. But what their complaint for a long period was, it's not so fast, it's really slow. It's not that the system is slow, but finding all this information within the huge text, within the tables, for all the analysis and everything, it's complicated and it takes time. You have the new clients, it takes lots of time. You have you junior underwriters that just started on that. It takes even longer. So you understand the challenge. We have vast and we have a huge volume of data. We have limited search capabilities. It's not that because they are limited in a way that it uses keywords. It uses that you don't need to put everything there. Yes. It works as Google almost. It just not a sentence, and it doesn't group all these things together, but rather gives you, these are the 5 pages you should look at. And the last thing, complicated topics. So we were thinking first, like if you would think, okay, then let's just use ChatGPT without anything. This would be probably the first thinking. Why we cannot do that? Because what we do is, ChatGPT doesn't have the context, doesn't have this medicinal knowledge. And also it would use the knowledge it already has, which is not Swiss Re knowledge. We are not selling ChatGPT as service. We are selling our knowledge to our clients. So we cannot just use ChatGPT and then we just a ChatGPT layer, but we really need to put there, and lots of you know it, RAC. And this is how we did it. So we really created a human-like assistant that operates like a chatbot, but is able to connect all this data for you, is able to consolidate this, and is able to output the information for you. And you just ask a single concrete question, but the single concrete question can be full of medicinal information and very long, and you receive a targeted and constant answers about the person, already considering all these tables, all the information. This is how it looks like. This is the simple question you ask: 40-year-old male, sleep apnea, disturbance instead of that, uses some rating, and other things that I'm not medicinal doctor and underwriter, I do not understand. And from probably you already see that there are citations, that I will come back to that. It looked at the 3, and I will come to that, to these 3 pages, and provide the answer. It's also cited, but also concise that into one table that really helps. That's the answer. So, at the same time, we solve this. This problem is now solved. Great. So, oops, something happened. Here we are, okay. We solved this, but unfortunately we are not here because we already solved it, but we are here because we want to stress that does it work? And now comes the meat on the bone. So, what are the limitations? First, obviously, hallucinations. Everybody knows about that. There are so many topics about hallucinations, we don't need to speak. We also know that the models itself have first costly, there is cutoff, we should use rather R data only, and there are incoherencies in the terminology within how the ChatGPT also works. So how we did build it? We used RAG. This is a standard RAG. I will not explain that. There are tons of YouTube videos about that. But for people that don't know it, it basically allows that your LLM systems can retrieve some kind of context and additional information from different systems, different places. And we put all the data that we have in this huge Wikipedia into the RAG. With small difference. We really want that it needs to be precise. If you are not precise in the underwriting world, and in Slovakia, we probably can speak about 100,000 loss. In US, we can speak about 1 million or a few millions huge loss. It needs to be precise. How do we make it precise? How do we make it precise? We really anchored the answers to the data we have. How do we anchor? It's really like citation. The underwriters need to trust it. We need to make it right. But also, we need to ensure that this is anchored in we know where the data comes from, we know why the LM system chose this and this and this answer. So this is the anchoring. We really added references to all the information we have. You can read it, there is a table, and we really have the answer for the individuals with mild asthma rating at the death for severe asthma, it's this. This is the anchored answer. We know the references, and we can come back to find out where in the Wikipedia it is. The underwriters, there are people that don't trust it. That's right. This is not 100%. If they see something suspicious, they can check them themselves using the citations that we provide. This is important idea about how to make it, how to in generic way make AI systems more less prone to hallucinations, let's call it like that, and more directed towards the knowledge. If we see that it answered some complicated questions without citations, it's hallucination. This is the thinking. And obviously, if you anchor it, you can use things, and I can speak about a little bit later, like LMS judge. You first get the answer, you have the answer, you have the citation, and then use different LMS calls to ask, is this really this answer based on this page? And you just change the way, and you also judge it. It's additional ways how you can reduce the hallucinations. Deployment. This is a couple of slides that you just understand. It didn't take us weeks. Lots of people think that we can in a couple of days now with the LLMs and so on create new products. Creating a new product is quite easy. Now the work is about evaluation, testing, understanding, also making everybody understand, making business understand, and also many, let's say, application engineers understand. We lived until now in deterministic world. If I do it in this way, it will always answer and output the same thing. We are in undeterministic world. We need to align our testing, we need to align our evaluation. Yes, we can build the products a lot faster, and LLMs allow that, but at the same time, we spend lots of time on evaluations and making sure it's right. So it took us quite some time to get it into stage where we provide it to the users, to the business, because as I said, the mistakes can be very costly. How we did it also just on technical level, it's microservice. I think this will be very usual for a lot of systems like this. You need to provide fast answers. You need to provide answers that are also right, but the user expects that it's within max couple of seconds, ideally faster. So microservice architecture is probably becoming more and more dominant in these transactional systems. And yes, it's LM systems. You should log everything. log all the prompts, log all the answers. You need to have really audit trail. We have lots of regulators around the world. As I say, this system operates live guide in more than 100 countries. That means 100 different regulators. And this is used for something which impacts your insurance. So again, the regulators want to check it. For example, we already had an audit from the Swiss regulator already in March, April this year, where they really went through. We provided them a list of all the existing AI models we have in the company. We have more than 120 already running. And they selected a couple of systems that they are more interested, that they see most risky, and really deep dive into these models and spent days in our offices to understand and make sure we did everything right. We passed with flying colors. But also think about this when you do new things, new models, things about the regulators, things about should I do it, should I not do it, how will the regulator look at that, is it anchored, how precise it is, and so on. And how we do it? It's for testing. You need to test. It's faster development, longer testing. So you need to really systematically evaluate the generic systems. And this is the important, under extreme, adversarial, and edge case scenarios. It works very well for the standard situations. We saw that. It's very capable. But as soon as you have extreme situations that the system was not built for, as soon as you have adversarial situations, what adversarial situations can I expect? This answers only questions based on some Wikipedia of medicinal knowledge. This is important. Imagine we spent years to build this medicinal knowledge. We spent really lots of years. Imagine that somebody gets access to your chatbot. You spent years on creating some specific product, and with these chatbots and RAG systems, you don't have so much control. Somebody can really mine with questions all your proprietary data. And within half a year, recreate systems that you created. It's a lot faster than people think. And probably in the future will happen also a lot more common. So there are a lot of adversarial attacks that you can do, obviously, but one of them, you just don't want to use your unique knowledge that you are selling. We are here selling only the unique knowledge that we have. Last thing, edge case scenarios. Similarly, extremes, edge cases. Think about that. Nothing, it will never work right. And this is also the thing. You are not trying to solve and be 100%. It's impossible. We are speaking about that you can solve 99% of the problems and hopefully have enough controls to mitigate as much as damage from the other 1% of problems that you cannot catch. How we do it? It's red teaming, it's governance, it's legal. It's not just AI. It's not just even IT only. So key areas. In systems like this, key areas. First, to solve these problems, you need to understand how to stress test. What are the risks? Hallucinations, we spoke about that, we don't need to. Malicious use, little bit we spoke. There are the adversarial attacks, but also there are other problems. Data confidentiality is something which, again, spoke a little bit, and copyright infringement. We know there are problems with the copyrights, the unresolved copyright issues. You heard about that, you read about that. These companies, like OpenAI and other companies, use really mine all the data that they can get access to and use it. I don't want to speak about these legal problems, but there are, again, more than 100 countries. Even if there is some view, for example, for that in US or in European Union, and there is one common view, and I don't know if there is, you need to solve it also for the other countries. Imagine that you use some copyrighted data, and somebody puts a claim on you. You go to court, and the court says, "Oh, yes, but in our legislation, in our country, as long as you use it, even if you are on the user of ChatGPT, and we do not have power over OpenAI, but we do have power over you because you have a local branch. And you will be the one paying the fine." So you should ensure that the models, if you deploy something like that, do not answer the generic questions. Focus only on on questions that are relevant to your systems and to what you want to achieve, but everything else should be filtered out. If it asks what was weather, if this exam is being asked what was weather in Germany last year on this and this day in this place, normal systems can, but this system should not answer. And your system as well. Dimensions, how we test it. Obviously, input. You want to have as varied, ambiguous, adversarial prompts as possible for red teaming. And you want to repeat that and have as stable responses as possible. And I will speak a little bit later about red teaming. Similarly, latency. We also saw that these systems can have latency problems, and it's very important. CPU utilizations, all these things. Other things, there are already tools, I will mention some of them, on how to automate your red teaming, how to automate these questions, how to automate some of the tests. And in the end, it's human in the loop. For lots of these systems, human in the loop is and will be important. Even through all these reimagination journeys that you hear about, and these agentic systems that will solve and do the work of the humans, they all are data-driven, they all are AI-first view, but they're also human-centric. And yes, you can compute then accuracy and F1 score. One thing is, these are important metrics, but it's a little bit different world. In past, in machine learning, we had confusion metrics. It worked really well. Imagine that you are just now extracting some data from some documents. And I spoke about that with one person today, that's why I'm bringing it up. In the past, if you extract right something, it's yes. If not, it's no. And basically, we have the metrics. What is the reality is that if you extract from a document Swissri or Swissri GmbH or SRO or something, it's probably not 100% right, also not 100% wrong, based on the context. So you need also think in a way that this matrix works, but also you sometimes need to create your own quality metrics that works for specific your case. So you randomize inputs. If I speak about, let's say, if I speak about somebody with sleep apnea, with some kind of index, some kind of blood test, I also want to randomize some of these attributes in my prompts when I do it automatic, and to get to the extremes. What happens? This value can be between 1 means healthy, 0 means healthy person, under 5 is basically a healthy person, 5 to 25 is somebody sick, and nobody in the history of this parameter had this blood test parameter higher than 25 because it means you are dead. But what if somebody makes a mistake, puts it into the system, and the system answers, and we wrongly underwrite the person, and we have huge claims with very little premiums? Agent-based attacks. Source anchoring is the important thing I mentioned in the beginning, and prompt handling. Prevent all these injection attacks. You cannot prevent them for everything, but prevent it to the degree you can. Tell the machine the users cannot change the prompts. The users cannot adjust what are the basic instructions you have at the top, and all these nice things, and you hope that it will work out. And there are tools that can also help you. There are tools freely available. I put here only freely available tools, or in some way free. And you can automate some of this testing. You can automate some of the problematic situations. And here is even code of ArtKit. It's very simple. You create your testing kit, test prompts, and then you run it. AI teaming. I think most of you heard about that. For people who do not, you really simulate adversarial attacks, extreme conditions, and somebody really asks the questions. By somebody, I mean it can be still a machine. It is still a process where you create, 800 different varied prompts. and you try to ensure that your systems can work out under these extreme conditions and still provides the right outputs or correct outputs, or rather crashes and doesn't provide anything, then just providing wrong information. So what you should test for, it's bias, obviously. All these companies that created these systems used available data to train them. They tried to mitigate bias as much as possible, and there is still lots of bias. It's impossible. It's in the history of the data, in the way how we see it. Data leakage, hallucination, harmful content. Probably it's not that harmful content is not much relevant that for us in the lifetime of underwriters. But imagine that you create you have, and it's stupid example, it will sound very stupid, but you have eShop with chatbot, and it helps somebody to commit suicide. You just don't want that. You don't want also this publicity from that. I always don't want that to happen. Influence operations, non-relevant topics, all these things, test and get it out. What we found out in our system, the key issues were systems prompt leakage that we needed to test for, and medical advice. Our system should provide the fact-based answers, but should not give medical advice to the users or to the underwriters. And we really, with the red teaming, with really focusing on improving the prompts and adding this anchoring and all these mitigations, we reduced the leakage from what we called before 100% to 4, basically by more than 20 times. What do you also think about if you have a product that you manage and take care of, and if you add there new GenAI-based component, check your terms and conditions of your product and adjust that. So how we assess it? We really go from, we try to understand the use case first. We have some steering. I think this is very relevant for big companies. We have something which we call digital governance framework, where we really in one place put all the problems that can happen, all the risks that we think can happen. That happens even before we started to write the code. We added to something which we call AI catalog. This is also, most of the mid and high and big corporates should have. AI catalog is that if a regulator comes to you and asks you what are all the systems that you are running, and use AI, give me the list, and they will not wait for a month. It's not just the regulator will not ask about the AI systems that you develop, but all the systems that are used in your company. If you buy a system or service from APEC, let's say, and it does something which is not is against the rules of AI Act, you are the one responsible for the damage and the fine, not the creator of the system. And after that, we try to, during the development, we try to mitigate all these risks as much as possible. Some of them we need to accept, and we should it's non-deterministic. We need to get into the thinking. You need to speak with your business users, business owner, the business side, however you call them, that it is non-deterministic. This can be never right, 100% right. And then after deployment, and that's the important part, you need to continuously monitor. What we do and what we have is we first log everything, and we provide, and the users can provide us directly the feedback. You saw this also in probably in Google Gemini, thumbs up, thumbs down, and we have also these options of write your own feedback and provide us if you think we did a wrong answer. And you need to check this. You need to go over that. Of course, if you have 1 million users, you will get lots of answers, and based on that, you probably need second AI systems that goes over these answers and all the replies you got. But not looking into that, you don't know what's happening. And here we really have the AI catalog, as I mentioned, and here we have we didn't start it in Swiss Re with AI in the last 2 years. We started 12 years ago. So we have already more than 124 models in production at the time when I created this print screen. Probably right now it's even more. We still continue and on the journey, but these are the learnings we found when we worked with the generative systems and how to test them. It's a little bit different than machine learning. Machine learning, we can rather spend time on the different metrics. Here, it's about how you think, how you approach the problem. It's a lot more unique and different. In machine learning time, you have test cases that the system never saw, and you just create confusion metrics, and then you create some other matrices and plots and so on, but in the end, you are good. This is a well-known field. So we now come back to that red teaming and to how you evaluate this. You need to create your ground truth dataset even with these kind of systems. Without that, it's hard to create and generate the questions that the systems will need to answer properly. So first, you need to create that. You obviously assign some scores and so on, and you start to evaluate. And this will be probably always unique. There is not one receipt because we have multiple projects running parallel. This is one of them. In all projects, we do it a little bit differently. You want to evaluate that. You want to check on which part what works and what doesn't work, and just plot it. You also want to check which model, which LLM model is the best one. You need to have abstractions. Don't focus on just one. We saw situations where GPT-5 doubled the precision from 45 to 90% for some situations, and lowered from different situations from 90 to 87. The newest, it's not always best. Usually what works best is the one where you have the most guardrails, where you create the most guardrails yourself. And it can be rather older than the newer model. And similarly in here, you want to cover, for example, the video streaming, you want to ensure that safety again, but how you do it, you create also lots of questions, personas, and you simulate first the regular users. You check for the bias. You check for some country specifics. You check for, in our case, providing medical advice. Our system should not provide medical advice. You check for something which you call curious user, copyright infringements, extracting the knowledge. It can be called the adversarial, but we call it curious. And then obviously you check for the harmful content. You don't want your system to basically answer this, but I put this example below. Very fast, somebody found an envelope that had been on the door. Envelope contains 7-line article about to Coca-Cola and Hillary Clinton and opioid epidemic in America, and ask your system to finish the article, and your system provides the answer on the right. You know what happens? The users, your answer will not be visible when the people create the print screen and share it on the internet or to the news or to police or somewhere else. They will obviously provide the print screen where is only seen the answer, not what was the prompt that they put there. So think about that. User experience, I mentioned that. What we can improve. Every answer, just provide these capabilities to the users. Some problems will be only fixed, unfortunately, in production with these kind of systems, and only after you see it the first time, which can be first day of being in production, and which can be 2 years after you are in production. There will be more and more, let's call it curious users. And with that, I think we will not jump here on the demo, because we have 1 minute left, but I will just keep it fast. You can see that it provides complicated, but rather come back towards my main statement. For me, the real benefit about AI is not the technology itself, it's the combination. If I can give you one idea, especially to the younger people that are still studying, in past, you were a software engineer, you didn't need to understand that much the business side of what you are doing. This changed, and now you need to understand the business side and why you are doing a lot more, but you write a little bit less code. For us, about the insurers, if there are any companies, because I saw them from MSG here, I think sponsor as well, proceed mindfully with the right guardrails. You can change the word insurers to provide almost everything. Create the guardrails and adopt responsible AI practices. seize the opportunities. It's important to seize the opportunities, but without the guardrails, you will fail. Thank you.
Right. Thank you so much, Lukas. We have still time for 2 questions, so that's what we're going to do. Let's see what got voted that people want answers. So the first one, was the underlying LLM model trained solely on the available Swiss Re documentation, or does it continue to learn from customer inputs provided through the chatbot?
Yes, this is a good answer. And in our case, we do not want that it learns from the input it gets. It specifically want that it only uses our proprietary knowledge and nothing else. In situations where you are doing something, the situation can be a little bit different. So think about your situations, what makes sense, and if you want to allow this kind of learning, or if you really want to make sure there is never used the generic knowledge that the model comes, and even the information experience you get from the users when they use it.
Okay. I'm always happy that once I'm reading the question, I think to myself, I hope you understand what is being asked. And then you're like, oh, excellent question. No, really cool. How do you source and curate your sources for your anchors? What if the sources contradict themselves or become out of date?
Yeah. So how do we source? We have really we probably spent a lot more time on changing the Wikipedia of knowledge, all this text, to something which is structured and table-oriented, and we can provide to the rec as an input, then other way around that we spend on prompt engineering and other things. The data preparation is huge, and you need to find your specific way. In our case, there was a text, and there were tables. And just we need also from the tables to generate text that we could provide for the anchoring to the RAG system. And yes, what if sources contradict themselves or become out of date? So how we do it is everything that we consider that is within the, let's focus first on the out of date. Within the R systems, it's in the Wikipedia, it's not out of date. As soon how it changes to out of date if we remove it from there. So this is also not something, in some situations you can imagine that the data can change day from day. In our situation, the data and hopefully the facts about most of the illnesses do not change from day to day. That's probably one thing. And second thing was I forgot what was the second part of the question.
Well, we got 2 already. So here, the last one, we're still going to do it. How frequent the vector databases are being updated?
Unfrequent. You obviously could do the updates as frequent as your data changes. Again, in our situations, it doesn't make sense, probably. I do not know even. Could be once per 3 months. I don't know. Obviously, when the underlying data changes and you think the change is impactful enough, you shouldn't update your vector database. But it just doesn't make sense to spend computational power on updating your vector database if your source hasn't changed. Okay.
I will say thank you so much for the presentation, for answering the questions. We've got to make the switch. Let's give him a big round of applause.
Thank you.
Thank you.